In this video, I will give a quick overview of the code editor. It is the first part of two. In this video, I will focus strictly on the coding aspect of the code editor. The code editor can edit three types of assets: script, shader, and utility. Script basically contain user code and logic code that you will be using in your application. Shaders are strictly reserved for GPU materials, where you can edit either vertex, fragment, and, if supported by your core profile, compute shaders. And finally, utility. Utility are basically allowing you to modify the NRG editor. On top of the NRG API, you will also be able to use the theme, graphical user interface, and IDE. With utilities, you can create visual tools or modify the NRG editor interface. Take note that the utility will not be part of your final published project. It resides and lives only within the NRG editor. The code editor is basically divided in two sections. Basically, on the left side, we're having multiple tabs that can be accessed, and on the right side, we're either going to have the text editor or the node editor if our asset is actually using node. The first one at the top is going to be our navigator that display using the same kind of hierarchy that is currently present inside your library to display only the type of asset that can be edited within the code editor. To select a specific asset for editing, simply click on it and the code will be loaded. The second tab is for Node, the Node browser, which I will handle in the second part of this series. The third one is for reserved for the call stack. There is an integrated debugger within the code, the NRG editor, and it is accessed from the code editor, and the call stack and your frame will all be located in here in a visual displayed in a visual way. The last one that we have is basically to do some find and replace within your code and a few options to tweak the actual text editor. Three other buttons are there for a question of convenience. If your code is actually based on time, you can always play to increase the application time, pause, or step one frame. If we're moving on the right side, we have our main toolbar, which is divided in multiple sections. The first section basically allows you to build, activate or deactivate node, save the current asset. The next one are strictly reserved for node and will be handled in a separate tutorial. The third section is for the visual debugger integrated into the NRG editor. Take note that shaders does not have access to the debugger. It is strictly to debug Lua scripts. Shaders, since they are running on GPU, does not have debugging functionality. This section will change based on the type of asset that you're actually selecting. The last button allows us to close and cut the link with the current asset that has been edited. While debugging, we have the option to debug either locally or remotely. If I had multiple devices connected to my project, I can select which IP address I actually want to debug scripts on. The last section contains a quick jump to function. If I create another function here, let's call it on test, I am going to be able to switch between my two functions very easily. As your scripts or shader will become longer and longer, it is very useful to be able to jump from one to the other using just a simple click of a button. We talk about the debugger. Let's start to test that debugger and show how we can set breakpoint and have access to our call stack. I am having here a simple scene here with a camera, and I'm going to edit my script here to actually do something and actually make use of the debugger. I'm going to create a local variable that I'm going to call A, and I'm going to assign one, local B, and I'm going to assign my script to my camera here. as you might know by now, NRG is basically event driven. So based on the type of object that you're using, you will call specific or generic event callback. At any time, if you are not sure about which object respond to which type of callback, you can also access the API documentation from the help menu and then API documentation. It will open the default browser of the current operating system that you're using, and after that you can start digging to the API and the object events that are responding to a specific callback and trigger. In this case, I'm having a camera. It is a renderable object, and it responds to the onDraw function, which will be triggered right before the camera is about to draw anything, to send any command out on the GPU. So I am going to create first some variable here, and I'm going to actually clear my screen. You can see that I have code completion by default enable using the Lua standard way of calling classes and object. I am using two dots so I can have access to the function for that specific module, which is GFX, and I am going to then access the graphics and clear buffer and color buffer. So basically what I'm going to do on draw, I'm going to clear my screen, and I'm going to have another local variable that is going to call C, and it's going to be A plus B, and I'm going to print C on my console here. I am going to build that script, and right away I have my output that is displayed, and I can simply then, with my camera selected, object property, open up a new thread and simply drag and drop my script, and automatically I start seeing that my color buffer have been cleared, and I start printing 333 over and over and over. So it means that we do have a callback, a trigger that is accessed while we are running our onDraw function. I am going to set a breakpoint. To set a breakpoint, you can simply click on a specific line, deactivate, reactivate all breakpoints, which are basically on an asset basis, so you can choose which one will be debugged or not. And to start our actual debugger, we're going to click the little bug here, and by default it will then hit my breakpoint and fill the information about the current event on my call stack here. If we have a closer look of what's going on here, most of the time we will have these two variables that are basically created for us at event break time. We have one that have the current event, the local event, that give us indication of everything that was actually set when that breakpoint occur, which scene, which render layer, which camera, which object, and this specific variable can be used in your code to run your logic. Since it is event based, you have to understand that all these scripts can be reusable. They can be assigned on multiple objects, and the same code can be determined a different route, a different path based on the type of object or based on the type of event that currently occur. So scripts are 100% reusable throughout your application based on the type of object you're connecting, or assets or objects, resources you're connecting them to. We are having the this keyword that is basically giving us indication about what type of user data actually call that script. And if we have a quick look below here, we have the full information about where this script is coming from, what is its current state, which is currently debug. We have script, the name of our asset, at untitled, the name of our scene, and camera, the name of our object. And we also have the thread number where this specific coroutine is actually running. So we can also at any time, especially when you start to have multiple things going on in your application, you have also maybe multiple devices connected, it is also very useful to be able to visually pinpoint which object have actually triggered, or which type of asset have actually triggered that breakpoint. If we start digging inside our current frame here, I'm on the first line, I do not have information. And if I use my basically my debugger control here, as I move on to the next line, I start to have local information that get filled in. At any time, as you can already notice, the tree view here can become very lengthy very fast. You can always type in here the name of the variable or the name of the property that you want to access, and it will be highlighted automatically. You can also shrink down the amount of information that is displayed on the call stack by disabling up value, enabling or disabling up value, global variables, local variables, user variable, and temporary value, and get rid of all the null pointers. By default, not everything is actually set, so if I enable that, I'm going to be able to see all the properties that are actually set to nil, to 0. But for a question of convenience, it is turned off, so you only deal strictly with the information that actually have been set. As I continue using my debugger control, this is to step over the next instruction. If I had a function call, I can step into that function and then proceed with the rest of my execution. As I continue here, I can see that on my current frame, I got my data that are actually filled in into my call stack. And to disable, I simply click here, push play, and it resumes. As soon as I'm going to click it again, I can directly have access back to my breakpoint. We had a quick overview of how to use the debugger, and now let's go a bit more in detail about the kind of variable that can be presented to your user. I am going to disable the breakpoint here and continue my execution, and here I am going to create a new variable that I'm going to call my value, and I'm going to set it to 0. And I'm going to do the same thing, but I'm going to call it local, and then my value to equal 1. As I push the build button, we already noticed that our event respond to that our object responds to that specific event, and we have also access to the user variable here that no results are found. If I push the build button, you will see that now my value is accessible from my user variable. Local variables will always be local to the current script, to the current thread, but we can declare variable that will be used globally and then will be reflected as a user variable. From there, we can click the variable button and set parameters about the step for each time we click the little spinner here. What is the minimum value, the maximum value, if it is a constant, if it is locked to the user, can the user actually change that value or not. And like this, you can create basically customizable scripts that will have parameters that can be dynamically changed by the user or in code. Before moving on to shaders, let's talk a bit about utilities. I am going to select my utility from my navigator, and I'm going to create a simple call to actually draw something on screen. By default, the register function will be created for you, which is basically the entry point of a utility. I am going to now create a new widget, and I'm going to access the theme module, and I'm going to create a new dialog. I'm going to call it my dialog, and I'm going to specify an actual size in pixel, accessing my iVector2 module, and then set, and let's say 480 by 320, and I will leave the icon blank. From there, I'm going to be able to access the widget function, and I'm going to say set all visible, and I'm going to set it to true. So basically, I am using the theme API to create a new dialog, and the resulting widget accessing the widget function, which is part of graphical user interface module, I'm going to call set all visible. And as I push the build button, I have a custom dialog using the current theme of the IDE that is created for me. From there, you can add buttons, text box, spinner, whatever you want to create either tools for your application or importer, exporter, or to run lengthy process. Once again, take note that the utility will not be published in your final application, only lives and reside within the editor. The last type of asset that our code editor can handle is shader. And basically shader have to be actually connected to a material. I am going to create a material, and I am actually going to set that I'm going to edit this material by simply drag and dropping it in the material property here, and my shader asset is going to be placed there, which I'm going to drag and drop this way. And once again, if you remember what we talked about the script, we also have a user variables here. In terms of a shader, it will work on uniform variable. So let's say that we got uniform and then vector4, and let's say that I call it my color with a big C, and I'm going to build that. Next step will be to assign my color to my fragment color to actually make it in use. Instead, that the variable will be automatically discarded, because we have a new option here, which is basically optimizing automatically our code. If we disable that, we have just plain code the way as we type it, and if we enable this, we're going to have the optimized version of that code. As you noticed previously, I did not have my color assigned, so it will be automatically discarded by the optimizer. Now I am making use of it. If I click the build button, I will have access to my color here. That can be modified by the user in the same fashion that we use when creating user variable script user variable. And in this case, my color was a big C, but if I write it in lowercase, it will be considered as a vector4. I got access to it from here as a single vector4. The big C will actually declare it as a customizable color. Instead, it will be handled as a simple vector4. To create variable that will be actually fed by a script that we want to hide from the user, all we have to do is to add a underscore in front of it. Let's say that I call my color 2 underscore my color, and I'm going to add it to my fragment data. And as I build, you can see that underscore my color, it is not visible. When you're basically specifying underscore in front of a uniform, it means that you will have to manually feed that data using a script before drawing the material, since materials can also contain script. Using the onDraw, most likely even callback, you can have access to the current shader and the current uniform that you want to fill in, and then manually update it. If they do not have underscore in front of their name, it means that they are user-based and can be edited as you see fit using the graphical user interface. This basically concludes the first part of our code editor overview.